Good evening, everybody. Welcome to the first of many presentations we're going to be having this year. It's the first time we've convened. Unfortunately, again, we're having to migrate online. We had planned to have this as a first session of the year in Oslo, but for reasons obviously known to everybody that we haven't been able to do that, but I think we're going to have a good evening anyway. We've got four very impressive presentations for you this evening. So I just thought good to welcome everybody. I think I had about 50 people reply to the invitation that I sent out only a couple of days ago. But if we have as many as that online, it will be a good event. So I just, as a normal thing to do on this occasion, I have to say thank you to the sponsors who you can see to my left. We'll be sending out letters to a lot of these companies for this year to see who will be interested in sponsoring us again, because without them and their good generosity, we would not be able to do what we do on a regular basis. I do hope that once we do get back to in-person events, that we'll see a little bit more some food and some drinks, and we can ensure that the money that is donated by these kind companies is spent well for us, and also for furthering not just that, but survey within here in the Scandinavian countries, Norway, Sweden, and particularly over in Scotland as well, that we're trying to embrace. So for this evening's event, we have, of course, four very good presentations loosely based around subsea cables. It was actually quite difficult to link all four, to be honest, but I think it will be very good, especially having the likes of Equinox with us as well to talk about geosciences. It's always going to be very interesting for us. So I would encourage, we have the Discord chat room open. The link was in the email that I sent out to everybody. It's also on the NOSP website, so please do go onto the chat room, have a quick chat with people. I think he doesn't even realize it, but Chris Cooper has already bought pizzas for everybody in the chat room, and I think I've just offered some gin and tonics. So please go into the chat room, get chatty. That is where the questions will need to be asked. If you do have any questions of the presentations that you see today, go into Discord. We have Carlo, who's also on the NOSP team. He is there and will be adjudicating and collating some of that, and hopefully greasing the wheels for some of the questions that will come through. So please don't be shy. I know it's hide behind the screen, but I believe that we've got four very interesting presentations tonight. So don't be shy. As we are familiar with, we're talking that just before we came, that it was a familiar crowd of presenters. So don't be shy with your questions. So as ever, always hear from people who want to speak any presentations. We are very, of course, to get a themed evening. It makes more sense. It makes it coherent and gives some people to really get there into. So if there are any people listening here tonight and watching, please do get in touch with me, with any of the 6 members of the team. Be more than happy to receive any proposed or themes about for evenings. So on that note, we've got another evening planned on the 4th of February. It will be, as mentioned, in Stockholm. We will do our best as an in-person and online event. We had a combined inaugural, for want of a better term, online and in-person at Bergen, and it was a big success. We had 30 people there, 40 people online, so it was a good turnout, really. I've also put in here on the screen, you can see the Seabed Mapping and Inspection Conference. It's not strictly NOSP, but a lot of people who are associated with NOSP will be there. Always good experience and always very interesting presentations. And then Oceanology follows a week later. And then we will have 2 more in-person and online events in Bergen and Trondheim before taking away. So that note, bring in who is our from Equinox, and he will be talking about the reflections on survey and integration activities for offshore wind. And obviously, Tim, this is a pretty hot topic at the moment. Everyone's talking about wind. In every company who's not involved in wind wants a bit of wind at the moment. And just generally getting on board with the renewables. So, Tim, you've got a master's, I think, in geosciences. You've been with Equinor a couple of years. Tell us a little bit about yourself there.
Yeah, so originally I'm a geoscientist by background. I've been working in Equinor for 8 or 9 years now, can't remember. And yeah, my background is actually I have a PhD in volcanology of all things, but a lot of applied geophysics in that. And so I've been I've been in Equinor for a while, and I started in exploration in Equinor. I've been working towards offshore wind and survey now for nearly 2 years in this position. But I've migrated myself basically from an exploration geoscientist through various production things into our academy structure, helping teaching and learning, and then came into kind of survey in general, but with offshore wind as one of the primary focuses. Good.
All right, well, I'll bring in your presentation here. Tim, thanks very much for taking the time to join us this evening. I think everyone looks forward to presentations from some of the big hitters like Equinor. So I'll disappear from view now and leave you to it.
Yeah, thanks. Thanks everyone for coming to attend. I'm going to cover just kind of an overview of my reflections. Everyone is quite new to this industry. And we'll just kind of walk through just a few reflections on what activities and integration for offshore wind there is. Like I said, my background is more of a geoscience than a hydrographer or a surveyor. But I hope to kind of give you a flavour, a little bit of offshore wind and what's important during this activity. So, I'm going to comment why is this interest in offshore wind? I've got 1 or 2 slides on that. And then I'm going to discuss what's important for offshore wind projects that affects us in survey disciplines. A comment on some of the common challenges, and then reiterate the importance of integration, and then kind of summarize this in some of the challenges we have with data management and different activities around this. So why offshore wind? And I think this is stolen from Rystad Energy, but I think it's a really interesting figure. This is the capital expenditure, CapEx, for oil and gas versus offshore wind for Europe. And as you can see, the predicted expenditure for offshore wind will exceed oil and gas for the first time in 2022. This is a huge change, and it kind of speaks to why our company is interested in this and why you're hearing about it all the time. So this is kind of the starting point of the talk. Starting to see this big increase in offshore wind, a lot of offshore wind activity, and this big change in investment levels. And Equinor's ambitions in all of this, these are all on our website. Is to our ambition by 2030 is to have installed 12 to 16 gigawatts of offshore wind. That is a large amount, and I'll get to why that is in the rest of the talk. It also reflects our ambitions towards CO2 sequestration and storage, and it's also showing how we're also investing a lot of our R&D expenditure into low carbon, energy efficient resources. And I won't speak too much more about the strategic ambition of Equinor. There's a lot to find on our web pages and in the public domain, but I think this is a really strong and very ambitious target, and I can maybe explain why. So I just want to make a very quick comment on offshore wind in Norway, as this is the theme of this talk in a way. And this was actually published in 2011, I believe, and it's evolving at the moment. Offshore wind in Norway is coming. It's a bit behind a few other countries at the moment, but it is coming, and this is on our website. We're teaming up with external and other companies to look at these interesting areas, and there's a lot of focus on this in the offshore in Norway. It's a little bit behind other parts of the world, but it's I have quite a few colleagues working on this. Just to kind of remind everyone what the difference is maybe between oil and gas and what we're looking at here, and this is it's a very famous image of, I think, the Hornsea wind farm by Ørsted. And it's just trying to remind people, that the main resource here is wind. The wind energy is the primary driver for this. This dictates lots of things about the wind farm. So unlike in general, and a lot of oil and gas companies are looking into wind, but there is a big difference. The resource is not in the ground. The resource is not optimized from the ground. It's the wind resource is the key driver for everything, and the placement of wind turbines, the selection of wind turbine sites, it's all around this, and this dictates the economics. And it's just showing a few nice images of what's called the wake effect for offshore wind. So this is where other turbines interact with neighboring turbines to reduce the entire energy yield of the site. But this can be mitigated somewhat by different planning, or it's something you need to factor into your cost estimates for a site. So I just want to kind of go through what is an anatomy of a wind farm. This is probably very basic for people here on the call, but it's maybe good to just recap. This is just taken from our publicly released information on Empire Wind. So the big wind farm in the US that Equinox are developing at the moment with our partners BP. And just using this as kind of an example of what things are. And, we can split a wind farm into these kind of core areas. One is the lease area, and then development area within this, where we will develop where we'll position our wind turbine generators, the offshore substation, inter-array cables, and then we have to get this to land. So these are the export cables, and in Empire Wind there's more than one of them, and each one of these cables, there's 2, I believe, in Empire Wind 1 and 3 in Empire Wind 2 to handle the capacity. And then there's optionality in these routes. And then we have the landfall areas, so where we approach the shoreline, and we have to consider different approaches to the shoreline. And then we have the onshore routing to a grid connection somewhere where we interconnect onto land and into the infrastructure for the US. And all of this makes all of this offshore area needs to be surveyed, and there's various different tools for that. So what the surveys input to, and it's a bit of a busy slide, but it's just to try and reiterate what is the importance of survey here, and what does it actually impact on. And survey is not just to characterize the seabed, shall we say. It's there to aid the foundation design and installation, the anchoring design and installation, the installation and design of the inter-array cables, so the cables between each turbine. We have to consider the marine archaeological significance of all our sites. We have to accommodate for the seabed movement, so scour protection and seabed mobility. We have to look for unexploded ordnance to make sure that we have safe and effective operations. And then again, we also have to consider all these shallow hazards, and shallow hazards include shallow faults, boulders, shallow gas in sediment, debris on the seafloor, and the list goes on and on. And this is why we're performing survey. And this is more or less the same on the export cable routes, with extra considerations maybe on trenching and trenching considerations and seabed mobility. So maybe a different focus in terms of the depth of investigation of some of the surveys. And this is maybe the difference between the lease and the export cable routes, in that we're trying to image usually to the base of the foundations, and I'll get to that in a minute. And then on landfall, we will do more or less the same kind of shallow seabed survey. However, when we call this trenchless design, this is where we have a horizontal drilled approach to the land, so we're not disturbing or trenching directly onto the shore. We can also consider specialist surveys, say seismic refraction, ERT, so earth resistivity tomography, and various other techniques to aid the design. And I'm mainly focusing on all the kind of geophysical side of this survey, and of course this all goes hand in hand with geotechnical surveying to characterize the subsurface conditions as well. And just, and then another busy slide, but just some of the kind of sensors that were just relevant for these areas, just to cover just maybe some of the differences between the two. And one is the lease area, having deeper penetration of the subsoil, greater to the 10 meters than the foundation embedment depth. So this depends project on project. It can be 50, 60, 70 meters deep, depending on the installed structure and the soil conditions, maybe shallower on occasion as well. But there you need to shoot a seismic, single or ideally multi-channel ultra high-res seismic. And we're seeing more and more use for this and more uses, specialist uses for this as well. And I'll get to some of those. But we're also seeing the increase in the 3D multi-channel seismic to help characterize these sites. And then special techniques along the cable routes for identification of like non-magnetic buried targets. And that's becoming very important. And I'll come back to that in a bit when I talk a little bit more about the export cable routes. So some of the challenges we face in a lease area. So this is I believe this is Sheringham Shoal, and this is just an example of a high wind tampen with the high wind tampen floating spar design here. And some of the challenges we face is that the survey areas can be vast, and I'll come to that on the next slide. And it's quite a nice example I got from a colleague on this that I included. But these are much bigger areas than previously we've done for oil and gas. And not only that, we also need the survey design to maintain flexibility in the layout. Changes in the layout happen for various reasons. There could be you've got more information on your wind resource, or you've had another permitting consideration, or you can't locate on the site because you've identified hazard. So your survey needs to accommodate for this, and maintaining this flexibility can be a quite challenging, actually, on areas, especially with without 3D data covering the entire area. There's an increasing demand to characterize the subsurface over larger and larger areas, and again, the sediment mobility over large and large areas. And this is a data challenge. It's a processing challenge. And it's a challenge everyone faces to try and get these projects done in the time frame that they have for the developments, which are quite accelerated compared to oil and gas projects. And to kind of re-emphasize as well, there's highly variable local requirements depending on where you are in the world. There's a lot of variations in your environmental impact assessment, which all affect your survey considerations. So it's a challenge to plan and optimize a survey in all these areas. This is just a slide, and I apologize for the quality, but it's showing how big some of these wind farms are. This is Beacon Wind, our lease in the US, Massachusetts, and showing it on a map of London and a map of New York. Showing just the size of it. It's the circumference of the M25. It's a pretty big wind farm, and this is also compared to Johan Sverdrup. The acreage is even bigger than some of the biggest oil and gas fields on the NCS. So it's just showing that these wind farms are big, and also the amount of installed structure on these wind farms is a lot. It way outstrips anything that's been done on the oil and gas project, because each turbine is more or less spaced at 1 nautical mile apart, say the Beacon Wind is. And so there's I believe over 140 positions just on Beacon Wind 1 alone, and I think nearly 300 on the entire lease that can be selected. And you think about all that infrastructure that's got to be included. It looks simple enough. You see this, and then you see this, and this is, we haven't done any survey yet. This is just publicly available information on approach to New York Harbor that you have to also factor into all of your survey planning to try and understand, okay, where can I go? What are the limitations? What's affecting my survey planning? What's affecting my routing for a project? So and these are the major shipping channels all the way into New York, and you can see how Empire Wind Lease now fits within the picture and why it's the shape it is. And these are all considerations for a lease area. And then for an export cable route, I mean, this is this is maybe the theme of this talk, really. And I just conclude this nice diagram. This is actually looking out over the Empire Wind cable route, or proposed cable route, from the Statue of Liberty. So this is how close we're coming into a very industrialized area, and this causes its own problems. In old industrialized areas, there's extreme numbers of targets in the subsurface. There's also industrial activity and runoff, which causes really big problems with acoustic blanking, meaning we can only image down to a few meters in some cases in areas where there's basically a lot of sediments that have been contaminated in the area. And we also have to accommodate for understanding those and disturbing those. And this is feeds into our kind of sediment mobility estimates and studies, so that we can prove to our partners, to the local parties involved, and to the US government, that we're not polluting or overly polluting the area by installing things here. And this is just some of the considerations, and there are special considerations everywhere in the world with the permitting requirements and the right-of-way challenges, and in the US especially with private landowners, also that is not necessarily present in other parts of the world, where you have to secure right-of-way over lots and lots of individual landowners, which can be a challenge in itself. Just again to remind everyone, and a lot of people know this on the call, it's just so all the geohazards we see also need our survey input. The marine archaeology, really important. Seabed mobility, of course, is just a fantastic image from the USGS. This is a approach into San Francisco, showing the height of some of the sand waves, mega sand waves, in mobile on the seabed in the approach to San Francisco. And we have these slope stability issues as well. And one thing we're seeing more and more of is the problems arise from buried objects that are not easily detectable, like buried boulders, especially in nearshore environments in northern hemisphere with lots and lots of glacial sediments. Buried boulders become a problem, and different techniques for imaging those are something that we want to look at. I just wanted to comment one slide really on these changes, the changes towards the ultra high resolution seismic, or ultra high resolution, and why this is becoming more common in the work we do. And it's one of the pieces where I come into the can assist a lot of hydrographic surveyors, and why I'll be expanding a lot of people in geophysics here is mainly because we're seeing this increased demand for the characterization of the subsurface. We just showed how big some of these wind farms can be, and you want to understand the lateral variability of your soil model. If you just take a lot of point samples through geotechnics and you don't understand how they all relate to each other, you can think your estimates very, very wrong. And this is one of the things that's more becoming more and more common. It's basically the standard now is to integrate these geotechnical results with seismic data over large areas. And the seismic data can be, like I said, various flavors. You can also use sub-bottom profilers for anchoring as well. But this is just showing kind of image from Iwes Fraunhofer here, just showing trying to understand the lateral variability in the soils. It becomes very important when you're installing very deep monopiles, and you're either installing the monopile itself, so understanding about pile driving and the piling capacity, but also your installation, the lateral step out of soil properties away from your turbine site for when you're actually installing the structure. And it becomes really important to know laterally if you've got a change in, for example, your soil types. It's just a kind of image here. So, just kind of coming back on this, it's just, the importance of integration, and just really reiterating this again for big, large wind farm sites. And common integration projects, the alignment charting and various other things. That's great, but we're also starting to, develop deep integrated subsurface models that input into foundation concept selection and design. We can build shallow 3D subsurface models to assist with cable burial analysis and various other things. And this is the kind of work that's kind of ongoing with a lot of people, but it's trying to tie all of these different data sources and experience together in one area to try and really understand the complexity of the site, and to plan a safe and effective installation and design for the site, but also to make it for the lifetime of the site. And I think one thing to also reiterate, though, is just how big a data challenge we have in big projects like this, and everyone is starting to face now. So, we have our responsibility to our partners, our responsibility to our joint ventures. We have responsibility to the government and the government regulations and their data requirements, which are different in all different countries. We have our own data standards and archiving, and we have our inbound contractor data deliveries and outbound to all of our engineering contractors. And managing this is no insubstantial task for a large wind farm. There's over 27 surveys plus that make up Empire Wind, hundreds of reports, thousands of folders, hundreds of thousands of files. And that becomes a big data management challenge that we want to effectively manage. We want to effectively give the right information to the right people at the right time, and this is something that we're working on quite a lot with now. So to kind of just conclude on all of this, there's many projects coming up globally, and what's the challenge now is there are a lot of new countries opening up for offshore wind, and there is then a lot of maybe immature is maybe the wrong word, but it's more the regulations and the regulatory bodies are still being set up in many countries, and they're still finding their feet with what they need to request from data, what they need to request from us, what they need to request for a large infrastructure project. I think this is affecting everyone in the industry at the moment, where we spend a lot of time both internally and externally trying to understand changes in regulations. And then it's great that we have these large areas and we collect all this fancy data, but we need to have the time to analyze and evaluate this data. And one thing to highlight here is that many wind projects, they operate on an accelerated schedule that's even way ahead of oil and gas project development. And this is one challenge we find. We've got bigger data sets, more integration over larger areas, but less time. And that always is the challenge. And then just to kind of summarize some of the technology and the innovative developments and maybe some of the things I just think might be important or are going to be important in the future are techniques and adapting technologies from probably the oil and gas industry for 3D, ultra high resolution seismic over large areas to full lease extents. Quite common, we see 3D data shot over smaller areas along corridors, but it will start to become more normal that this will be shot over the entire area in the future. I think there is a lot of increased uses for 3D sub-bottom profiler for different burial assessments, and this will be really interesting to challenge the geological conditions. So not just identifying buried targets and products in the subsurface, but really helping characterize the geology of of a cable route in 3 dimensions in a much more 3D model based format. I think we'll see again a lot more autonomy. We'll see, especially in the industry, and a lot of techniques pioneered in the oil and gas industry. We'll see starting to migrate more and more to offshore wind applications. And some of the things that I think are going to become more and more relevant are, using the seismic data, using this new data in new and novel ways, which has been pioneered by many people and has been, some of the strengths of the oil and gas industry, and is the kind of quantitative seismic inversion and interpretation to be predictable about soil properties and how they will affect foundations. I think all this modeling and integration work is going to start to come to the forefront in the next few years. And the question mark is, is the ultimate aim to have a digital twin of the surface and subsurface for our wind farm, like we would have for our engineered structure? And I think that could be the way forward for all this. So with that, thanks for listening to me waffle on about offshore wind, and I hope that gave you a bit of an introduction of what were some of the challenges we're facing and some of the background on offshore wind.
Tim, thank you very much. That was very interesting. I've got a number of questions for you personally, and I've got a couple that have come in from Discord. To me, I can see only a greater involvement from survey for this compared to maybe the historical use of oil and gas, the historical energy of oil and gas. Is that fair to say? Do you feel that that's also the case, and that survey has a greater role to play here in the years to come in wind, from a acquisition point of view, processing, reporting, and GIS management of data? Yeah,
I think that's definitely fair enough to say. I think there's a huge number of projects that are coming up, and the amount of survey in the areas are a lot larger, and nearly all countries are exploring to meet their carbon emission targets. They're all exploring the involvement that they would like to get in offshore wind, and I think that it's only a good thing for the industry. I think it's going to be here for a long time to come, and I think for a wind farm, there's like I said, a lot more installed structure that needs a lot more data than oil and gas projects in some cases, and I think that's going to be it's going to be the future for survey for sure for a long time to come.
So for someone like myself who's involved in inspection and survey, and inspection, I think I should be able to get to my retirement age quite comfortably. But on that front, on that question, at the moment, one of my big worries within where I work is where the manpower is going to come for this, because we see that historically we haven't been very good at bringing in new blood into the industry. Is that something that Equinor, as such a major player, is that something they're aware of and doing something about to ensure that there are actually capable people to do this? Because at the moment there's a finite amount of people involved in survey. So what do you know, can you even answer that question about what Equinor are doing to maybe contribute to some of the personnel and the resources that are required to manage all this data in the future?
Yeah, I mean, I can't comment too much on that, but I definitely see the kind of the issue, and I see there's going to be an increased demand for this kind of competence. And recently I presented with Peter Swagel, who works in CCS in Equinor, and we presented towards the University of Stavanger. And we were challenging the geoscientists in the groups, both the staff that were there and the geoscience community as a whole, that they also need to expand out and understand the differences in some of the things that have been shown here. They need to understand differences in survey, and they need to understand survey techniques. And that should be an integral part of a geoscientist training in the future. So, this is not necessarily, how we're addressing the maybe survey challenge in terms of people, but it is challenging the kind of status quo that academically and in universities, that there is a big focus or bias towards reservoir geoscience, and I think that we're trying to encourage universities to move away from just that focus, but to, you know, and the way to do that though is they have to integrate with the survey disciplines and surveying really in general.
Yeah. All right, thank you. Those are, I'm appreciative of the fact that there are actually other people listening here, so they have questions. Those were just mine. But Art Legrand, he was asking, how do Equinox survey for Uxos? I mean, it's a very, it's a pertinent point, especially here in the North Sea. So what is your chosen weapon of choice or methodology, or is there one? How would you best see Equinox going about that, or the subcontractors working for Equinox?
Yeah, I think it's a big challenge, and you know, I think I'm not the right person to ask really in Equinox about this, but there are several of my colleagues working in industry, different industry bodies to try and understand this a bit better. The way currently that we would survey for Uxos is using magnetometer TVG surveys, but then doing visual inspections on those targets, much with dedicated contractors, and also with contractors that are doing like desktop studies for different kind of things to characterize the history as well. So it usually follows a survey plan for the Uxos. Firstly, kind of desktop study and the summary of the area, but then into dedicated survey and then dedicated inspection. But we're participating in a lot of different industry bodies to try and understand this challenge.
Okay, there's another question actually came in from Jack Dow, and that's actually kind of on the back of this one there, because you mentioned magnetometers and that's various products, but how do you, and you did, I remember, touch on this towards the end regarding the, I don't know, I can't remember it now, but it's the Pangeo system for looking for non-ferrous, non-magnetic objects. I mean, I know that there's not the money in wind as there was in oil and gas, and the Pangeo equipment, the imager is more expensive. But is that something, is that type of equipment you see beneficial, despite the maybe potentially higher day rates, for looking for non-ferrous and magnetic objects?
Yeah, and I think it depends largely where you are in the world. But like, you know, one of the challenges that you have is you're in nearshore areas that were previously glaciated at some point in a lot of cases. And when you've got glaciated areas, you've got tills, you've got boulder clays, you've got various other kind of interesting challenges in the subsurface. And understanding where those are is really important. And they're really important, but larger boulders, they're really, really important. For pile drivability, understanding how you would drive a monopile into the subsurface, but also they can affect, you know, your ability to trench. So I think in certain cases, it depends a lot on the geological conditions. But yeah, I think we would actually see that more in a way, because of we've seen such problems with this in various projects, even documented, you know, in the public domain about the challenges, you know, you can face with shallow subsurface boulders. Yeah.
All right, so it's good planning as ever and good management of data. So that's probably the key here. But Tim, thank you very much indeed for your time. We're already running over, but hey, who cares? All right, thank you very much. I'll take you off the stream now, and I will bring in Ola Peter from StartNet to bring us on to onto our second presentation of the evening. Good evening. Oh, that's wrong. That's Chris. There you go.
Yeah.
Sorry about that, Ola Peter. Good evening. Good evening to you. Thanks for joining us. Another, I'm sure you will deliver the goods as well, as Tim just did. Very interesting presentation from him. You've obviously been with StartNet a few years, 9 years previously with Fugro, so you've got a lot of survey experience and knowledge, and that obviously bodes well for your time in StartNet. So And you've got a very interesting talk, the importance of having control of your seabed data in case of an emergency, of course, and that's very pertinent given what actually happened over in Tonga recently with one of the cables breaking. So I thought I'd throw that in to show the people that I actually read the news. So I think, Oliberta, I probably will just bring in your presentation and allow you to, where is your presentation, chap?
Yeah, I'll just get my, sort it all out and do the sharing and just hold on.
Yeah, no problem at all.
Yeah, so some patience here and we'll find the right to share. So
there we go. There it is.
Yeah, you see
all
it.
Right. There we go.
Good
lad.
Nice
okay.
Picture there. So yeah.
All right, I will leave you to it, and I'll speak to you in about 20 minutes. Thank you very much.
That's good. I'll start my clock so I can keep the time. It's a big topic, and it will align bits and pieces of it with the previous presentation, and I'll go into the details when this happens, and you have a need to repair the cable, and the importance of having control of your seabed data, and how valuable it is. So I'll give some examples here from the Oslo Fjord and the Skagerrak cable repairs from 2020. We had 3 incidents in 2020, and a lot of experience gained from that, and worth sharing with you. So I'll just, yep. Quick introduction. Statnett is the transmit system operator in Norway, and we are responsible for the main network on land, and also the interconnectors offshore, which I'll keep my focus on here, and also the inshore cables, about 2,600 kilometers in total of subsea cable, and connections to all our neighbors, so Sweden, Finland, Russia, Denmark, Netherlands, Germany, and UK. So we'll look at those interconnectors here. That's also been a hot potato in the media, and everybody with the energy prices quite high, and the gas prices as well. A lot of, a lot of talk about how the interconnectors influence on the price. I'll not go into that political discussions, but we can see on the screen how it works with the exchange between the Denmark, Germany, and the flow of current. So it's the prices are set the day before, and you have an exchange of current in the direction with the highest demand, and normally also who pays the most. So you can see here, it's not only in Norway that has this problem with locked-in power. In the end, you have very low prices in the north, and then you have high prices in the south, and that goes for both Norway and Sweden. The Nordlink was installed recently in 2020, and the NSL is still on trial and installed last year, doubling the capacity of export. So, but we'll look into what happens and how we deal with it when these cables break. So there are different types of cables. We have oil-filled or self-contained fluid where you have the oil in the middle here in the core, and they have these PEX cables where the insulation is kind of this PEX material, and then you have the mass impregnated cables, which mass impregnated non-drainage, it says, and usually have the paper insulation filled with oil. And those are the normal for Statnett in the long interconnectors. The MIND is used, and for the inshore HV AC cables, we have either these oil-filled or these PEX cables. So the mass impregnated is also the DC. So that's a difference. The long interconnectors have the DC since the loss of power is higher in the AC. We'll come back to this because on the Oslofjord cable, we had a fault on both this and this type of cable, and on the Skagerrak, we had a fault on this type of cable. And there are some differences that we need to go into. But when the fault happens, a lot of questions arise, and I work in the emergency response team. So when did it happen? Where is the fault? Why did it happen? And where is the cable? Do you know where the cable is? Sometimes, especially on the old cables, there are uncertainties. And what's the seabed condition like at the site where you have the fault? And that's very important to know, and also shown in the previous presentation. So when you try to find all the answers to these questions, you need to compile the information, and that's what I'm going to show you bits and pieces here of how some of these we give answers to some of these questions, and how we work to get them. So we had 3 faults in 2020, and we'll have a quick look. So first question is like, where is the fault? And as mentioned by Stuart here, but you have the incident in Tonga, and the thing is, it's not very difficult really. You send a pulse down the cable, and you measure the distance to the fault. But how do you know it's the fault? So there are different types of fault. You can have a low ohmic or high ohmic, and normally we have a low ohmic where you have a breakthrough, or at least you get earth connection, and you can see a change in impedance very much similar to a sub-button profile, really, where you put the pulse down, and you get a reflection where you have a change in impedance, and you need to know the velocity of the pulse. That's what gives the distance. So if you have the velocity wrong, you will also get the distance wrong. But you have some measures and reference points you can align to. So for instance, you should have a good idea of how long the cable is in total, and you can also, if you have some joints, you can use them as reference points. So that's this is the speed set here and this is from the fault on the Skagerrak cable, and this is from the fault on the Oslofjord cable. So that's the time domain reflectometer. So and that gives us. We also have other ways when you have a fiber optic, and in the Oslofjord cable we have fiber optics. and that's more accurate than the TDR measurements from measuring the pulse. On the fiber optic, you get the exact measures on the meter. And this is from the Offshore cable number 6 that was broken, and we'll come back to that. And I've taken out from our dashboard where we have real-time, can take out the real-time data, and also look back in history. So this orange line was when it was broken, and you have a clear cut here. You can see that there is definitely the fiber is broken, and that tells us also that it's a big damage. And the blue line, continuous blue line, now is after the repair, and we can see that the cable has been repaired afterwards as well, working well. So let's move on to the good stuff. This is our damage 16 in February 2020, and this is loss of fjord cables. Big tanker had drifted off from this refinery area and got over our cables, and where I said some of them are PEX and some of them are oil. And what happens to the oil cable is that when it's ripped off, it starts leaking oil, and that's the priority, to stop the leakage. And we need to pump the oil into the cable to prevent water ingress. So and that makes it quite urgent for us to stop the leakage and get that fixed. On the right image here, you'll see a HISAS image on the background. You'll see, or a sonar image, and we see the plot of the AIS track of the vessel that caused the incident. And we'll go into the details here and look at it. So when it happens, all mans to the pumps, or find all your pre-survey data, collect everything from them. It should be easy available. Get all the details about the cable, so you can start preparing for the repair. And so alignment charts, GIS data, recent surveys. We had some recent survey data here, and get it all ready and ship it over to the ones that's going to do the work. So this is the good stuff, and the lucky stuff for us as well. The incident happened 16th of February, and this is very close to where Kongsberg Maritime have their facilities, and they were to do some tests as well the next day, and they could pass the area of this site. And I just made some clips here from the images we got and the level of details. And this was extremely valuable. And when we got this, it made life a lot easier. We could see the cable had been broken off here. This is a cable that's been dragged southwards, and we had cables that's been dragged northwards and southwards. So we could see that it's cable mayhem, or what you call it, but that made us prepare for, and it could also narrow down our search when we get to the site with the big vessels. So we could start detailed planning straight away based on these data. And the cable number 6 here was the most crucial one, and we needed to find the oil leak. And it might look simple when you look at this, but when you get out there with the ROV, it's muddy. The site is almost no visibility, and it's hard to navigate. So when you have this as a background image on your nav screen and you line everything, it makes such a big difference to comparing if you didn't have it. So just made our life a lot easier. And on the nav screen, we could put this on the background. We could check out. We did the inspection just when we arrived out and looking for the oil leak, and we didn't see anything. But we could navigate, and suddenly we could see some oil droplets, and I'll show you how it looks. So in the media, it looked like it was a lot of oil coming out, but when you get out there, it's not so much. And this is the oil coming out from the seabed, and the cable is down there. So that's what we need to get to and get to the deck and sort out. So so when we were looking for the oil, this is what we needed to find out, and luckily we could find it quite fast based on these HISAS data. So the timeline for the fault so Sunday 16 we could got the report. We have a call-off agreement with the PRSI, the Pipeline Repair and Subsea Intervention. They could allocate vessel Olympic Zeus, this one. Monday we had the Hugin maps available. We could understand the situation better, and we on Wednesday, 4 days after, we arrived at Nexans port and completed the mob the same day. We could transit to the site and start inspection. We found the oil leakage, started to dig out, got the cable on the deck, and we got all that done in 5 days, which was, I think it's quite hectic days and to get everything ready. So quite exhausting process, but it worked, and this is what we got on deck. This is the oil cable, and you can see how it's imploded. The cable just that is hollow has just imploded and narrowed down into this one. So that was for the Oslofjord cable. It's a long story, but I'll just keep to the first phases on the repair. Maybe we can take another time or another presentation. For the Skagerrak cable damage, it's a different seabed. The damage was from a troll, and we saw from the TDR measurements, we could estimate the positions out here, which we know is a difficult area. We have these extremely large sand waves that's moving and makes exposures to our cable and make it vulnerable, for the trolling activities that takes place. Luckily, we had the North Sea Link project coming up there with the Nexans going out for the installation, and we had that vessel coming out here and do the survey on these sites before it was heading for North Sea Link. And we also had some other equipment on board to do the tracking of the cable. And we could see that we had a problem here. The large, it was extreme deep at some sites and all the way to exposure at some sites. So, and this is 6 meters deep, and this is exposed, and we assumed the damage to be somewhere here. We can't visually see it, but we decided to cut here because this was reasonably accessible. So if the damage was here, we will still manage. So yeah, see, my time is running out there. So how we did it: tracking your cable, put a tone to the cable, tested some equipment, and we see that when you put a tone, we can measure the cable all the way down to 6 meters, which is a good development. And tested 2 different tracker tools. And some will be presented at Geilo as well, I think. So that's commercial for the Geilo presentation that will come up, and usually 22 hertz. And here you can see it's 3.5 meters down. Just an example of how it's visualized and how we prepare to do the cut. It's a big topic. I could talk on this for a long time, but that's my time. So thank you. Just some bullet points. When you have the access to the data, you can make early decisions. I recommend to acquire new data when you have a repair if possible, and not only base it on your as-is data. Maps and images, very good to have, and it's easy to show and explain rather than just in writing. And when you have it, it's better risk management, and in the end, what management like to hear, it saves cost. So special thanks to Kongsberg Maritime, Nexans, iSurvey, and Aquadyne that was involved in very much of this seabed. Yep, thank you.
Thank you very much, Ole. Very interesting. I always find it funny that people take for granted the fact that they can use their mobile phones and they have power, but they don't realise that all this is buried cables under the rivers, estuaries, in the ocean. And it was only recently with the Tonga it was thrown into the limelight. Especially in the fact that I remember reading that it would take a month for the vessel to get there to repair that cable. So. You were able to mobilize at short notice, but again, it's good planning and proper management of data. So you mentioned something called a PRSI, which, if I remember correctly, is pipeline repair and subsea intervention. That's obviously what they're going to have to do in Tonga. Use the same principle, I assume, with you in Oslo Fjord. Can you explain a little bit about that? How does that work?
Yeah, it's that's for the Tonga thing. The fiber optic or telecom, they have a similar setup as the PRSI. The PRSI is very much administered by Equinor. It's the pipeline repair and subsea intervention pool, and you can become a member there. And Statnett has become a member there. And it was initially set up for repairing pipelines when you have the same incident for a pipe. Which of course is more severe than this, but we see it's beneficial to use the same model as for the PRSI for cable repair. And so we aligned there, and anyone now with subsea cable can become a member of the PRSI and lean on the agreement that's there. And that's by this, you can have this short notice and call off. And it proved very useful in this situation, and we continue to build on that from Statnett side.
Absolutely. Very interesting. I didn't know that existed, a collaborative effort to obviously save money and ensure that people continue their lives, I suppose. But interesting. On one of your latter slides, you mentioned applying tracking of cables. So traditional methods use tones. Is that still the case? Do you have to apply a cable to the tone to track that?
Yeah, it's that's the thing. Yeah, it's you get better values when you have a tone to it. As you see, so here we could measure it good down to 6 meters, and it doesn't take much amps to get it, but you can also track if the cable was intact, and it is possible to track on the harmonics. It's still a AC component after you convert from AC to DC. It's still a AC component on the cable, which you can use as long as it's power there to track on. The data doesn't get as good as if it was a tone there, but it's sufficient to track. So it's important to know, and the Orion system has proven very well to that one, and when you have a tone, it's also the other system that's works. So
yeah, very good. All right, I've got a quick late question in here from Tim. Actually, it was their first presenter. Are you using any active cable monitoring solutions?
Yes, we are, and that's also for the ILO. Okay. So you mentioned the Tonga incident, and I showed the slides with the OTDR, and with the fiber optics, it's a lot of other feature you can measure. You can measure temperature, you can measure acoustics, and everything on the fiber. And for those who want to know more about that, join the YILO conference. My colleague will will have a topic on the DIS and DTS system, which is called. So yes.
Very good. All right. Well, on that note, we'll wind up the questions. Thank you very much, Ola, for your very good presentations, and you've really plugged YALO. I think everyone has to get there, not least for the quality skiing that is offered.
Yes,
that's why I'm going. But okay, very good. Thank you. And it's usually a good booze up as well. Thank you very much for your time, Ola. Good stuff. Right, now I will be joined by Martin Vikmar, who's also part of the NOSP team, a 6-man team. So Martin, welcome this evening. Good to see you again. I think I only saw you a couple of times. I've seen you quite a lot this week with lots of planning towards it. I mean, you've been in the business a while. I mean, you started Clinton a few years ago. It's a big success. You know, what did you write? They were shortlisted. I'm not going to go that far, actually. Suffice to say, you've done very well. You know, you've been on NOSP since its inception 10 years ago, and you're a valued member of the team. So I'm thoroughly looking forward to your presentation this evening regarding some of. I hope it's to do with. I don't remember all the details, but some of the carbon neutral side of it. I'm sure you'll dip into that. Yeah. So. Yeah, I think it's going to be a very interesting presentation. So I think what I'll do is really just hand it over to you and take it away.
Thank you, Stuart. Thank you. Yeah, so I realized that it was 5 years I had a presentation at NOSP the last time, which was 2017. And then I digged into what has happened since this, and it was a lot, actually. But first of all, then a little bit about Clinton, for those who haven't met us before, and then the tools that we are using and the methods that we are developing, and some results. I can't show it all, but some results and a summary on the future ahead. What are the future to go? So first of all, a small introduction to Clinton. We are 60 employees. working with geophysical surveys only, so we are not doing anything else than geophysical surveys in Europe. And we are then working hard with ISO 14000, as Stuart mentioned, with the environmental footprint and so on. And the purpose of Clinton from start was to bring smart solutions to the market that didn't exist. So that's the driving factor for us to be on the market. And it's great, quite great, because we are shortlisted as one of top ocean tech companies in Europe from a magazine. So it feels great that we are not in a magazine for turnovers. It's ocean tech instead, which I like quite much. And as Stuart mentioned, I joined Clinton 2015 and founded it together with a few others, and we have been on the market for 7 years now. We have our survey platforms. We try to bring the solution which makes the smallest footprint that you can have, but maintain quality. So in our fleet, we have a vessel from 24 meters down to 4 meters, which then can go sort of really near shore, as you can see on the image on the right-hand side. Is somewhere in Norway, and then up in Storm, which then is our largest vessel, which has been used in Svalbard as a SAR vessel. So we have 2020, we completely turned everything in it out of the vessel and started to rebuild it to our own vessel. One thing that we are talking about then is a sort of Clinton Internet solution and Clinton Unmanned solution, which means that since the startup, since 2015, we have in all our projects that we're doing, we are bringing the data back to the office. And of course, the reason for that is many. And of course, we don't need to have offline personnel on the vessels, which then will minimize the flights to and from the vessel. We'll also minimize the personnel involved in the projects. And you need no offline on board. You have no nearshore office. There is one offline team. It's not a sort of rotation of offline teams. It's one in the office. And if you need to be 10, you can be that. If you like, if you need in that project, you can access to all the key personnel who has been working with the project. You can talk to each other on the project they are working on, so you can sort of focus on the competence and so on, and bring the competence from other projects into your projects. Fast with the Teams meetings, as we are facing now. Then, of course, with Corona and COVID, I mean, this is something that we have used in all our major projects since 2015. We transfer around 75 gigabytes per day during our operations. We use Ava's software for workflow manager to build up the things you don't want to do. Ava is a great tool, and FME is a great tool to make those manual workflows automatic and do our unmanned solution. So there is no one working with that data. And in the morning, everything is in sort of packed as you have set it up in the morning when you arrive to the office, and you have slept and you are sort of you are really prepared for the day's work, and you can pick up your kids at the night, so to say. So by using this, of course, the quality goes up, the speed of our deliverables, the efficiency, and the cost goes down, which we really like them. And of course, one thing then, what you can do if you use this solution, you can lower the size of the vessels, and that, of course, is one of our core values in the company, then to try to reduce our carbon footprint whilst we're doing high resolution surveys. So Northern Storm consumes around 1,500 liters per day. And then if you take a traditional survey vessel, 4,500 to 6,000 liters per day is, there are vessels which consumes more than 10,000 liters per day. But if you just take a vessel like Northern Storm, you do and you take 3,500 liters savings, which then means that you have a vessel who consumes 5,000 liters, and you work for 30 days in a project. By choosing a vessel which suits the project better, you save 105 liters for 30 days. And of course, the yearly savings in fuel then is 1.2 million liters of fuel. So of course, that's sort of cost and also then CO2. And then the next development, which we are running now, then is to go with HVO100, which means that our vessels then consumes 1,500 liters, but then it's only 1/10 of the CO2 which is in that HVO. HVO takes away approximately 90% or 85 to 90% of the CO2 emissions. So of course, then if you compare sort of our vessels then with HVO100, you save around 4,850 liters of fuel per day, and then 30 days is 145,000 liters, which means that you save around 1.7 million liters of fuel during a year, which of course is a major KPI for us in the company to try to convince everybody to use our low emission solutions rather than any other larger vessels. And then you need a SIS for the personnel. But then of course you can also say that okay, if you have a smaller vessel, how can you deliver high quality data then? Because then you're rolling around. And during the developments of our vessels then is to try to make them stable. And what we have done then since 2015 is to install gyro balls to reduce 75 to 80% of the roll. And now also during 2020 we installed a Humphrey system, which is used in sort of the yacht industry to lower the whiskey glasses going backwards and forwards. But we mounted it on our new vessel, Northern Storm. And that one takes away then sort of 85% of the roll, lowers the fuel consumption around 10%. And it, of course, it also gives, I mean, if you live on board the vessel and it rolls around and it's completely flat, then of course it makes a difference. And then of course we are working with acoustics, and if the vessel is stable instead of rolling around, then the data quality will be better. So this is the Humphrey system on board the vessel. So this one is moving around every second, 24/7, and making the vessel be still. And then of course this will let's see if I can. You can see the size of it. So it's 2 meters. It's one on the other side. And then of course that's one of the key factors for our vessel then. So if you make the vessel stable, you then control the sort of multi-beam, the sub-bottom, which is mounted on the vessel, the USBL, which is still instead of moving. And then of course the quality will be so much better. The other thing is of course to have a multi-beam which has a really high resolution. And we have EM 2040 from Kongsberg on board our vessels with 200 to 400 kilohertz. And then of course we use AVA as I mentioned before as our single program to work on the multi-beam data. And then the next step is robust vessel, move the data over to Office, and then you need to have control over the quality of the installation with dimensional control, with a manual object. So we know that we are 2 centimeters from a known monument in Sweden, which then when you take all things into account, then you can create a map of this which is then a cable at 60 meters of water with a multi-beam. And then what you can do also is to survey a vessel with EM 2040 at 40 to 50 meters of water. And then you can also then survey in 10 knots at 40 meters of water to track this cable, which is on 40 meters of water then. And you can also then run a cable tracking of in 10 knots at 50 meters of water. And you can also then run in 10 knots at 100 meters. Then you start to lose resolution, of course. So somewhere between 70 to 100 meters, we are started losing resolution in that respect, that you can't deliver 10 to 25 centimeter wind size. But of course, it's a major difference to just go out and do multi-beam surveys and then try to stabilize the vessel instead of using a motion compensation unit to try to compensate for the motion on the vessel. So we are trying to make the vessel still. And then, of course, when you fire down the multi-beam with a beam, of course, if it's stable, then of course you get so much better data. So that's the sort of one of the major key factors, that we can go quite fast, really high resolution. And of course, you can't do that without the stabilization systems and so on. The other thing then, if you have a really good installation on the vessel with a hull mounted system, then you can use backscatter, and backscatter needs to be calibrated. I mean, it's just not to take out the data, just give it away. We need to calibrate the multi-beam. I mean, that's something that everybody does. But what you really need to do, if you're not doing it, is to calibrate the backscatter. And if you calibrate the backscatter, you align the different RX, TX transducers to be the same, which means that you get away of this striping that can be an effect on the data that comes out from the system. So there's a really good backscatter correction procedure which was released by Kongsberg. So if you haven't done that, do that. And then the next thing then is, of course, that if you are running backscatter, you need to do a lot of settings which you don't normally do when you're running multi-beam. I mean, to be able to produce a backscatter which you can use as a substitute to side scanner. So if you do the right calibration, the right sort of runtime settings, then the next step is to try to normalize the backscatter that we have collected. So what you see on the left, the image here is a raw backscatter image, and then you run it into Kongsberg's software, and then you can normalize the data so you get rid of the different stripings. And then when you have done that, you can start to use the backscatter to a tool, which then means that you can use it for sort of backscatter for geology, for habitat mapping. So what you see here is ripples in 10 decibels. So the ripples on the seafloor is on the screen, and what you see now is actually decibel going up and down. And on the right, on the blue image here, you see the ripples going as a multi-beam feature, as a height feature. But what you see here is the difference in sound absorption on the seafloor. You can also then, when you have done so many things with your backscatters, you get down to these details. This is 50 meters of water. So if you go to something like this, then you can start to use the backscatter to use it as a second tool to give you details of something that you really don't see on the multi-beam. So here's you see on A, you can see a feature. You can see it here in the backscatter. You can't really see B in the multi-beam data, the height data, but you can see there is something here in the data which is then something that is an anomaly, which you can then drag out by FME and then give you a list of targets. So A and A, you can sort of say you have a confidence level of 2, and B, you only get it on the multi-beam and not on the decibel value. So it's a really smart tool to sort of use the same sort of data and give it confidence level to your targets that you find. And of course, in this case here for B, we need to go in further detail. What can it be here? Can it be a geology feature? Maybe we go down with an ROV to have a check on it. The other thing is, of course, that you can pick out the objects. So what you can here's the multi-beam X, Y, Z data, and here's the target again. Once again, then in decibel, which means that once again you can drag out the target here and then the target here, and then you can have two images or two sort of objects, which then is from the same feature, which gives you confidence that there is some feature there. And the good thing, of course, with backscatter is that you don't have any positioning issues like with USBL and so on. I mean, it's a hull-mounted system, so it's not a lot of, or is no actually double features or so on. You can also then use it for, I mean, this is multi-beam for normal XYZ data, and this is from the backscatter image. So you can see that you are getting some more information here, which you can see on the multi-beam, but you get more information from the backscatter. You can also use it. This is an automatic tool from FME then. So what you can get here is then the different types of geology in the area. And the good thing here then is if you use traditional side scanner, this is backscatters, you can set the level here to 35 dB, and then you start to get the contours, but that's done automatically. It's not done by hand. So it's quite easy to drag out sort of different types of sediment in large areas. And then, of course, I will show you later on, when you go down on the site, on the wind farm site, or in the geophysical route survey site, or wherever you go down, then you take samples. Then you can use this information to enhance your product and enhance the digital model of the geology features that you see on the seafloor. And if you then take everything that we have discussed then so this is sort of a backscatter image that you can get out. So this is 50 meters of water up to 0 on the side. So what you see here then is, of course, that if you go in with the cable here and then up here you see there's some water lines here, some pipeline. Here is water inlet coming in. Here's some geological feature. So this is sort of EM 2040 0.335. A stable vessel with the work of dimensional control, and in the end you can get a really nice backscatter image, which then will be sort of like a mosaic that you go around in with no striping. It's no double target, so it's a quite neat feature. What you then also can use for the bathymetry and the backscatter is that you can then start to build a list with both from the bathymetry and from the backscatter, and then you can get out targets, and then you can export it quite easily and take out redundant targets. So it's a really cool feature to be able to use the information from multi-beam and backscatter to discriminate your targets. And of course, in areas like when you're building a wind farm and so on, and if you have like left-hand side there or this image here where you have all the boulders, I mean, it's so much, it's so good to be able to use a tool for the backscatter and the multi-beam together, and then sort of pull out these 50,000 boulders in the area instead of sort of sitting and picking them by manually. So it's a really smart feature. And of course, as I told you before, then if you use the backscatter to derive the model, and then you in the first case, then bedrock is from 0 to 6.5 decibel, and then the gravel is from 6.5 to 14 decibel, and then 14 to 22 is coarse sand, and so forth. And then you do sampling in the area to enhance the model, which means that it was no gravel from 6.5 to 14. It's rather 6.5 to 18. And then you just click the button, and then suddenly you have a new model of a large survey site, instead of sort of, oh, hey, let's throw this away and then start again with all the digging. So that saves a lot of time in all our projects. And also, as Tim was talking about, I mean, all this maintaining of all the data sets is quite tricky if it's not smart and convenient to handle. The other thing, of course, is that we talked about the URS and so on. We use Innomar Medium in all our projects. It's used in the major wind farm areas in Europe. The smart thing with our system then on Innomar is that the system is stable. I mean, we take away the roll, so it fires down. It's a massive system, and it's the Innomar Medium system, so it's quite big and has a big cabinet. The good thing is that it has a footprint of 3.5%, which means that when you fire it down to ground, it's only 3.5%. So it's, I mean, the sort of footprint on your soil and down in the sediment is really, really narrow. So you can sort of take away some of the areas which we have been working from. You don't need a URS anymore because we have so much information anyway. So Innomar Medium is sort of used in the major of our projects as the single tool, and it's a combination of both the normal sub-bottom and URS. I mean, there are, of course, I mean, if you really would like something, of course, there is good, of course, to use it. But for this large scale mapping, and I will show later on, for really detail, Innomar Medium is the kit. And of course, we can do 12 knots whilst we're doing this. So instead of going sort of 4 knots backwards and forwards with a lot of weather and so on, we do 12 knots and survey everything in 3 times faster than a normal survey setup. And then what you can then get is down to sort of 20 meters penetration in sand, because that has been the trick before, that the sand has been hard to penetrate with sort of sub-bottoms. But the Innomar Medium down in the sort of North Sea goes down to 20 meters in sand. And the good thing is that you can also use it, as you can see on the screen here, for tracking of cables then. I mean, not that you go straight over, but you can start to sort of pinpoint them. And what you can see there there's a 52 meters of water, and then 28 meters of water, and you go down 1 meter at this stage here then. So this is, of course, a major thing. And what we can do then is to start to build a model of the soil instead of small sectors. We can run a lot of these lines really fast, which means that you can then use this sort of model to model the sand, or you can model the bedrock, or you can model the clay, and then you can get the thickness of the clay in certain areas and so on. And of course, it becomes quite smart when you are using small, sort of larger areas or small areas where you are supposed to know what's in there and so on. And when you're planning in the sort of major larger wind farms and I mean in cable routes and so on. So what you see here then is then the bedrocks is gridded, and that goes through the sub-bottom that has been running, as you can see, a lot of lines, but then also a couple of cross lines to make sure that we have it. Cool. So really smart with multi-beam. I mean, Kongsberg is still pushing. It's 600 kilohertz, 700 kilohertz. It goes fast. I mean, it's smart with our from AVA. I mean, originally from the AUE. Now we use it as our in all our operations, the workflow managers. So the green buttons is there in the morning. So it's just to push it, of course. But there are, of course, things that you If you really need, and it's deeper than 70 to 100 meters, then of course, I mean, AV solution with a sort of EdgeCheck 900 kilohertz side scanner is really nice to use, so to say. So to sort of summarize my I had to go really fast because it was 35 slides, but to summarize, it's, I mean, you really need to make sure to have the right dimensional control if you're using hull-mounted systems for your physical surveys. To go over known features so you know that you're right. Make sure to use the right software for processing, like we are using Ava. And then, of course, we can use mosaics in 1x1 or 10 centimeter resolution instead of having a striped side scanner image. And then positioning is improved with hull-mounted system, automated target picking, use both multi-beam and backscatter. You can deliver 10 centimeter beam to 70 meters of water if you do it the right way. Of course, if you don't do dimensional control, you don't stabilize your vessel, you don't have the right echo sounder, that's not possible. But if you do that, that's the future. And of course, we can use it to acquire data in high speed. We only have 5 people on board, or 4. Then, of course, it's less HCQ in that respect that there is not a lot of people involved. We don't tow equipment if it's deeper than 70 meters, we do. And of course, we use a winch as well then. As I told you before, then less processing time because we're using backscatter, and we have less involved personnel, so there is no handovers. And backscatter for surface geology. And then, of course, already collected multi-beam data can be analyzed further ahead. So even though you are taking this, as Tim was saying, this large area, and you have it to 1x1 meter, it has, I mean, it's possible to reuse it many times, as we did with the backscatter, which means that you take samples and then sort of deliver a new grid in 25 centimeters if needed. And then, of course, if you're using a vessel which you are not sort of 40, 50 people on board, or maybe 12 or whatever you are, I mean, instead of, if you don't need to, then you can save 3,500 liters per day, or 100,000 liters per month, or 1.2 million per year. So that's, I think that's my last, was my last slide. So if you have any questions, bring them on.
Thank you, Martin. I love your enthusiasm, even after all these years. I think you've done a wonderful advertisement here for cable route surveys, really, and just some of the imagery you can get back from it, some wonderful, pretty pictures, and just makes it all very interesting and very, of course, necessary for safe installation of cables, regardless of whether they're interconnectors or inter-array cables. So very, very good presentation, Martin. Loved it. I'm opening myself potentially up to ridicule from the masses here, but I didn't realize you had to calibrate backscatter. So that was a bit of a revelation for me. How do you do that? And do you do that concurrent to a multi-beam patch test, or is it a separate test?
Yeah. So you do it as a patch test, and then of course you use software to normalize. You have, I mean, because the ceramics and the plastics and everything changes, so no sounder is like the other. So, or maybe someone at Kongsberg will shout at me, but you need to enhance them so you have the right level. And then, of course, I mean, if the backscatter is moving around like this, because you have a vessel which is having motion. I mean, it can be a large vessel with motion. But if you have it still and you shoot down 0.5 degrees into the opening angle to the seafloor, then of course you get sort of so much better results, so to say.
Very good, very interesting. That was good to know. That figure that you have on the screen there, 1.2 million litres a year. I mean, I know we've talked, and you said that you've done surveys that are actually carbon neutral. How much do you estimate you could save during 2021 by some of the investments in the vessels to make them more efficient? How much do you think you've saved?
Yeah, I mean, during 2021, we surveyed 40,000 nautical miles, which then equals to around 400,000 liters. And then if you take 1,000 liters, which we are doing as a sort of normal value, and then if you multiply it by 3.5, and then you're up to sort of 1.6 million liters, which if you use some sort of normal vessel on the market. So which means that it's what Stan says there. If you use a vessel as Northern Storm for a project for an entire sort of a year, you save 1.2 million liters for that year. Yeah. So it's that's what we have saved.
Very good. Long may it continue and be improved. One question from Tim, actually. I think he's still here. No, I think he's actually after us. But either way, do you have any experience? I probably know the answer to this one, actually, given the nature of your work. But do you have any experience using backscatter to support or understand seabed mining, which is probably not an area you've done much?
No, I haven't done that. But I mean, backscatter is, it's like, everybody knows multibeam in the industry. But backscatter is there, and it's a really smart solution because you already collect it.
Yeah.
And that's with the sort of the refraction in the sediment, which means that or absorption in the sediments, which means that you can get information from that for sure for mining. But I haven't tried it out. I only used it for sort of feature detection and geology and habitat and so on. So, but of course the core is to be able to deliver back, as you were saying, Stuart. If you don't calibrate and then you show that to some client somewhere, and then of course this backscatter will not be used because it's crap. Yeah. So to start with, you need to have a backscatter which you can use, and then of course there is major projects that you can use it in. Since we have been using it for the last 7 years in our projects.
No, very good. I think we did some work on that last year. I probably would be able to answer that question better than you, because of all the work we did with Mariano last year, or maybe the year before now. But anyway, thank you very much. That's the end of the questions, Martin. Really interesting presentation once again. So thank you very much for your time. I always appreciate it. Always good to talk to you, and I'll be catching up with you soon, no doubt. So thank you very much.
Thank you.
Okay. Everybody, we're moving on to our last presentation of the evening. Another familiar face for me, Chris Cooper from Nexans. Good evening, Chris. How are you doing?
Evening, everyone. I'm fine. See you all virtually here.
Yeah. Well, we've got 35 people still listened, which is good. We were up at 50 at one point, but still 35 is not a bad turnout. So I'm very pleased with that figure. So we've known each other a while. Chris, you've been with Nexans for a fair few years. You were with Doff and Guardline. No, not Guardline. Was it Andrews?
Guardline. Yeah.
It was Guardline. Yeah. So another person who's been in the industry. What I was going to say, actually, what's interesting about some of the presenters here, especially with Ola Pete, some of us, and you as well, with a survey background, not necessarily working directly in survey now, but able to find their way into other areas. So if any young people listening, that's encouraging, that to say that survey can open up many different doors for people. So I think it's an important to try to recruit people into this industry, and especially young people as well. So yeah, you're going to talk about what are you going to talk about? I've forgotten. I've lost the. I've lost.
It's basically. I was going to say, because the presentations we've had so far have been mostly focused on data, and data's fun and cool, but I like new electronic toys to play with. So that's what I'm going to talk about today. It's a relatively small kind of area to be applied to, but there's also the chance that people will see this and maybe see a way they can apply it to their own their own activities. So that's obviously interesting.
Good. Yeah, I think I mean, laser and cable and pipe detection are one of those stalwarts of offshore work, aren't they? So it's always nice we haven't really moved on from the cable, the pipe tracker, the TSS 440s, and the TSS 350 for cable tracking. So I'm always interested to see if there's new ways to do the same thing. So on that, I'm waffling, so I'll leave you to it, Chris, and speak to you in about 20 minutes. Good luck.
So yeah, I'm Chris Cooper, the principal survey engineer at Nexans, Norway. I'd like to just give you a quick intro to Nexans for those that don't know us. Describe how we previously solved this need on board our vessels, and then go through the different types of solutions that we looked at, our design constraints and process, and the path to the final product. And I'll show some slides on the testing and development, and then how the final product turned out, and then just finish up with some opportunities we see for improvement. So Nexans, we produce subsea cables. We have helped Ullapeta and Statnet with the interconnectors, producing a significant proportion of the interconnectors out of Norway. Plus other lands, other countries, and then also the export cables from wind farms that are really the core of our business. So we also look at the power from shore market. We have several factories around the world. Nexans is a worldwide business. The three on the left, the one in Halden is maybe our main subsea cable factory. And then we've just opened a factory in Charleston, USA, which is basically pointing towards the American market. And then we also have Fitsu in Japan. So that's where we produce our cables and deliver them worldwide. So we produce cables, but you know, we're really focusing on becoming a one-stop provider, and installation has been a thing at Nexans since very early days. We currently have 2 cable lay vessels where this technology I'm going to talk about will be used. The Nexans Aurora came into service this year, so a brand new vessel. Very proud of her, and not least the Nexans Skagerrak, which has been around for donkey's years, but still does a good job. We've got a barge that we can fit with thrusters and give it DP capability, and then right now we've got one trenching support vessel chartered to bury the cables after installation. So the problem or what we need is basically to record the angle of the cable as it leaves the cable lay vessel. This is basically to give us what's really a backup to our catenary calculation. Primarily that's done by the ROV, which is on the touchdown point, which then the position of the ROV is kept directly above the touchdown point of the cable. We then calculate the catenary, which will then give us the tension and allow us obviously to lay the cable at the right position and in the at the right tension. But as a backup to this, we've always used some kind of angle measurement on departure. Previously, this has been a mechanical measurement device. Unfortunately, I didn't have any pictures to show of it. Skagerrak's in transit, and I couldn't get anyone to grab a picture of this. But it's a large steel contraption, basically, which has to be lowered onto the cable and then gives a very simple angle output. One of the key things with this way of doing things was that it was required to be in contact with the cable, which we always see as a risk. It was maybe difficult to install. It has ended up subsea a couple of times by accident, which it isn't really designed for. And basically it's old technology with a limited service availability. So Nexans then decided to start a R&D project to look at what we could replace this technology with, and this brought us to look at three basically different types of device that we could use to get this information. We looked at the acoustic devices on the market. ECE, Coder Octopus, and Kongsberg actually started looking at a solution for us. Coder Octopus, this is their data from their website. Basically, here you can see the white is a inter-array cable being pulled into a wind farm monopile. Obviously, this could have been used then to pick points on the cable to give us the angle more higher up in the water column. So certainly it looked interesting. But then we also looked into vision technology. We went to Fugro for that because we'd seen some good presentations with them, and they seemed to have a solution that might work for us. And in the end, we also looked at using a laser technology. So basically, why did we decide to go the way we did with laser? When we looked at acoustic, it's difficult to achieve the correct angle. The video you just saw was basically shot from a chase vessel, it seems, because obviously it's looking across at the cable, whereas we would want to be mounting this on our vessel, not to have the extra problems created by a chase boat, and also it's a more robust solution. So we also looked at where we're operating. We lay cable from the rear of the vessel, which obviously where the thrusters are as well. So the acoustic environment at the rear of the vessel is not very good to use an acoustic device. When we looked at the vision technology, we were worried that we'd be able to maintain the correct amount of light on the area, especially as it would be shining back towards the operations bridge on Aurora. So that might give us some problems, but generally to maintain the correct level of light for this technology to work. And then obviously there's the problem of visual noise. Our cables have stripes on them for easy identification subsea. And then there's also rain, snow, hail that could interfere with that solution. So when we looked at laser, we saw that it was more widely used in both a subsea and a above sea level area. So that was good. But what it came down to, as normal, was that the laser was a much cheaper solution than both the subsea and vision, and we also saw there was less development needed than with the vision technology to bring it exactly how we wanted it to work. So, having decided roughly the way we wanted to go, we then looked for a partner. This is very far from Nexan's core business of producing subsea cables, or all sorts of cables. So we didn't want to look at making this in-house. So we needed to find someone who had experience with hardware, software, and machine learning. And to that end, we ended up with Iva, who've given me a bit of help with the presentation this evening. So if you have any difficult questions, I saw Ola was in the chat, so ask him, not me. So the benefits we saw with Iva were, amongst others, that it's software that we're already using. It's our navigation solution for the lay and trenching vessels. It's also what we use for some planning and visualization, especially on the as trenched survey side. And also we've also done some previous R&D projects together with Iver, cable route planner. Had a good experience there, so wanted to go back. So Iver took the ball, and those that know Iver software maybe will recognise some of the boxes here. The key thing is that the data is collected by one software, which is then configured, and then it's outputted to the helmsman's display, where the actual clever stuff happens, and gives us then the outputs to do our calculations. I've started testing the lasers using different types of medium to see how the laser and the algorithms reacted to different shapes and sizes. So you can see they did quite a thorough test plan here of different things to see how they worked. This is a test up in the office with the. This is actually the second type of laser that was used, pointing at the test object there. So then, following testing in the office, we brought the laser onto a vessel which was in use on the project. So you can see the laser back here, and this gave us quite a good insight into how well this could work, but also obviously some of the problems that we might encounter. So this was a very valuable exercise to get this actually mounted on the vessel at a relatively early stage. The key thing that we found there was that we really needed to move the sensor further aft of the cable. This is the cable coming off the vessel and entering the water. Our cables, just as a point of interest, they're not as stiff as pipes, so they will generally have a relatively vertical trajectory off the vessel unless we're in quite shallow water. So we then saw that we needed to make sure that the laser was a little bit further aft than we'd placed it on that test. There was also some, obviously, some software issues that were sorted out in terms of processing, and so it basically gave us a good start to work towards the final product. One of the learning points we had in the offshore test was that the selected laser sensor wasn't the best for the job. So then this different type of sensor was selected and brought into use. And that turned out to be a good fit for what we're doing. So back in the office, this is the laser scan from that sensor in an office environment. But obviously, we are not so interested in having a 360-degree view. So the next step was then to introduce a bounding box, which would help in many ways to define what we're looking at. This is the bounding box defined. Again, you'll see the familiar Iver software here. And then this is where the clever stuff starts to happen. So here we've started to separate the points which are associated with the cable from the points which are associated with the vessel, or the whiteboard in this case. And that gives us these outputs, and then they can be turned into a bullseye view, for example. Well, obviously, the key is the input to the calculations. So just to give an idea, this was again in the office, but with a mocked up vessel stern, just to give an idea of how this would work with the cable moving around, and do a good test there. So this is the sensor here installed on Nexon's Aurora. The sharp-eyed amongst you will see that it's pointing the wrong way. This is because Aurora is actually waiting to start the project, and at the start of the project we have to move these camera and laser boom arms out of the way of the cable. just for any startup, and obviously if we're doing any repair work where we need to move cable out using the A-frame. So this is the clever stuff. The cable is obviously has to be separated from the rest, the noise from the ship, and basically this is done using these machine learning algorithms. So the Gaussian mixture mode then fits the K clusters in the data, and then that's from which evaluates which Gaussian it came from. And then the Gaussians are estimated through an expectation maximization algorithm. This is an iterative method, finds local maximum likelihood estimates. And this basically turned out to be a very good fit for noisy data, where it can be assumed that each point is independent and identically distributed. So once these clusters are identified, the principal component analysis is taken into use and basically gives a direction and centroid for each cluster from the GMM step. So the direction vector would then give the pitch and yaw angles using trigonometry, and this is kind of coupled then with the centroid for the drawing and guard purposes, and at the same time it's estimated using the bounding box where the start and end of the cable is for the points to be measured. So just getting towards the end now. We've had, as you see, the system installed on Nexans Aurora for a little while now. We've completed one project down in Greece, a cable from Attica to Crete, and we're just waiting to start up one of the export cables for the Seagreen offshore wind farm off the Scottish coast. So what we saw was that in their tests, Iver had mounted this sensor in a horizontal. This is kind of a side view. It was a bit difficult to do these drawings in a good way. This orange being then the cable, whereas we felt that it was better to mount this in a vertical type orientation. So this is a kind of top-down view of the cable coming out from the vessel here and outwards to the sea. We'd like to see a more integrated software solution. There's a lot of different areas to be have values put in and checked off, and it's not one command area, but at the same time the guys and girls out there are clever people, so they should manage, and it's a pretty normal situation for navigation software. And then the last is that we see that with bundled cables, we might have some issues, so we might need to do further testing and updates for them. That was what I had. I hope it was interesting and a bit different, and I managed to explain a relatively random bit of technology well enough that people outside the cable industry understood what I was wittering on about. But yeah, if you've got any questions, I'd be glad to hear.
I thought that was very interesting, Chris. Thank you very much. One question, I got a couple of questions actually. A bit quiet on Discord, but what was the driver for this? I'm not sure if you alluded to that at the start, but what was the driver to get this piece of kit
I think
working for you?
We saw there was two things. We saw that definitely that the equipment we used for this initially up until this point was basically becoming obsolete.
Which was what?
This was as I tried to describe, this is kind of a large kind of steel cage structure that fits around the cable as it exits the lay vessel, and then this has a sensor which is physically in contact with the cable and registers the angle from vertical that the cable is at.
Right. Okay, so a laser can only go so far and through certain mediums. So is this possible to use this for touchdown monitoring, for example, or are we? Is that something maybe a pipe dream, or is it actually
No,
viable?
I think this is absolutely this technology is absolutely for the above surface application.
Yeah.
Absolutely. So.
Okay. And that equivalent of the
Obviously, if
laser
we
then.
use the acoustic variant that I talked a little about, that can also be used for touchdown monitoring, but only in relatively shallow waters. And at the end of the day, we always want to have an ROV on touchdown to give us more visual information about where we're putting the cable and potentially move any debris that might have come into the route.
Okay, very good. All right, very, very good. I really enjoyed that, and that's kind of wind us up now. We've actually only 4 minutes over, which is very pleasant. I've got to go up and change and put my little one to bed now. So, Chris, I really appreciate your time. I appreciate everybody's time. Those that have tuned in, Tim from Equinox, Ola Peter from Startnet, Martin from Clinton. I think it's been a really interesting evening. I've thoroughly enjoyed all 4 presentations. There has been a quick question come in from Ola, so hang on a minute. It could be a bit difficult for me to try and read this one. Perhaps worth mentioning that the laser in use is 32 fan laser, so it gives a good 3D representation of the shape with multiple hits along and across the cable. There you go, Chris. That was something we've included just to bookend the evening. But no, like I say, it's been a really interesting evening. For posterity, this is available on YouTube, so people can come back to it and refer to it. I think it's got a lot of relevance. And I think I'll just finalize this by saying we've got one more meeting at the, let me just take your presentation off there. We've got one more evening of presentations in about a month's time. We will be reaching out to some of our younger listeners to see if they want to get involved in some presentations. So until then, hopefully see people at Yalo after that, and London, of course, for oceanology. Worth plugging Yalo again. So thanks very much for everybody's time this evening. It's been worthwhile, and I look forward to seeing everyone soon. So Chris, thank you, and everyone.
Thank you very much for inviting me.
No, you're welcome, and on everyone on YouTube. Thank you very much, and good night.